and welcome to the Junkyard Love Podcast.
At what age do we learn how to have better conversations? At what age do we learn to have better conversations with ourselves?
What's up, guys? Welcome to the Junkyard Love Podcast. Today's recommendation, due to the current release date of the podcast, we're currently at the beginning stages of the coronavirus situation. So I'm going to recommend something that came up actually today on coronavirus, but it's going to apply for any time that this is listened to. It's about fear. This is a clip on Tom Bialyeux's impact theory. The title is Behavioral Neuroscientist Shows You How to Break the Coronavirus Anxiety Cycle by Judson Brewer. It's fantastic. I just finished listening to it before I finished up editing this episode, so it's fresh in my mind, but it's great to learn about fear, understand it, apply the scientific method to the fear that you're experiencing right now or you may experience in the future. Understand it. You can tackle it with stuff like this. So check that out. That's on YouTube. Behavioral Neuroscientist Shows You How to Break the Coronavirus Anxiety Cycle. Judson Brewer. Tom Bialyeux's is the YouTube account. Today we've got Kelly St. Onge. He's a good friend of mine, so happy for you guys to meet him and hear his view on the world. Drink some water. Sit upright. Let's go. We have Chia Dog, Kelly St. Onge in the house. Man, I'm happy to have you on. We just kind of went over the subjects that we're going to try to touch on today. I'm hyped. I think it's perfect. We did have a podcast before, but it was I'll probably still post it, of course, but we didn't really talk too much into this. Yeah. And I just think that knowledge is so much power in every way. So I think just learning about things, I was thinking actually about listening to this podcast this morning about the scientific method. It was just like a 45 insert from How Stuff Works. But and I was thinking about it, if I had to correlate it to my human emotions, how have I used the scientific method? And I was thinking when I was all right, I'm gonna heal my depression. I'm gonna get better. I'm sick of hurt. I'm gonna do this. I use the scientific method. I was like, what's going on? What do I do here? You kind of start testing it. You start troubleshooting, right?
Oh yeah, so, perfect. Yeah.
Yeah. So
yeah.
I don't know. I just thought it was interesting. It was kind of a thought that entered my head, so I figured I'd bring that up at the beginning. So
yeah, that's perfect because that goes right into I'll get there too, but right. That goes into exactly what we're gonna do today.
Perfect. Yeah. So any listeners, what we're gonna do today, we're going to dance around a few subjects that all correlate. We both have a little bit of things written down, so we'll try to. It'll be loose and fun, of course. We're just kicked back here, hanging out at the studio, but we are going to try to. Not dumb down. I hate that sentence. Of course, not dumb down, but just kind of conceptualize some things around math and science and quantum physics and all these things, which I know that sounds intense. So if those things are hurdles to you, I trust us. Just stick around.
Yep.
And just if you hear a sentence that doesn't make sense, just keep listening, and it'll loop back. I assure you.
Yeah.
It's something I have listened to. I listen to a lot of Eric Weinstein's podcast, The Portal. Yeah. I always send you those. I'm always like, Kelly, you're my math friend. What do you think about this concept?
That guy's so brilliant. I love that guy.
He's so smart. But he said that too at the beginning of one of his podcasts. I was like, that's kind of what I do have to do. I sometimes I float away for a minute while he's talking, and I'm like, I don't really know if I understand. And then I come right back, and it seems like it makes sense.
Oh yeah.
Yeah, just bear with us. I think it'll be an exciting, fun conversation. Happy to have you, Kelly.
Hey, yeah. Thanks for having me.
Yeah, heck yeah, man.
So I really wanted to create a podcast with you that I've been doing or having to study for the last couple of years here, and we're gonna go over computers, and we're gonna go into computers, quantum computing. We're gonna do a little bit of math stuff. We're gonna go into AI, and we're all gonna kind of very nicely thread all of this.
We will tangle them together.
Yes. So I'm going to start with, a computer is kind of like this magic box, right? Everybody kind of has an idea of, okay, this is a computer. It has a screen. It has a mouse. It has all these things, that a keyboard and such. And I'm gonna go right into it. So the computer has what's called layers of abstraction. So on the very bottom level is very complex and yet not very abstract, and that's the very layer of physics. So it will go into, as we get higher, it'll become less complex and become more abstract, such that, let's say, like you walk into a room and you see a bunch of lights, like a bunch of light switches all in a room, and you think, well, what do these light switches do? There's no lights, what do they do, right? So you walk into a room and you just really don't know what you're doing. Whereas when you get to the highest level of abstraction, less complexity, you will be able to walk into a room and you will be able to say, oh, I know that these things do this. So if I turn on the lights turn on. So that's kind of what happens, but I'll go into more of the light switch analogy here in a little bit. So on the very bottom level of this abstraction, there's the physics level. So it has to do with electrical current going to a switch, turning on, turning off. Okay. As we go higher, we have what are called bits. And these are important because I'll get back to these later when it comes to quantum computing. So a light switch is kind of like a 1 bit. You can turn it on, you can turn it off, right? So binary. So that's where the binary level comes from. It's the set of instructions that a machine can understand. We cannot understand. I mean, can you understand? So if you see like a wall of binary, Jake, can you understand any of it? Yeah. Okay. I mean, either can I. Like it's something that the computer understands really, really fast. That's the other thing about computers. People will go, oh, well, I got a smartphone. I got a laptop that does all this cool stuff for me. Well, computers are really dumb.
Yeah.
Yeah, I said it. Computers are dumb.
Oh shit. Alexa, I'm sorry.
So, don't hurt me. Oh my god, no way.
She heard it. I think it disconnected. I got one sitting right here.
Oh, okay. But yeah, no.
How are they dumb?
So computers are dumb because, I mean, literally, Mike, I have mine open right here, right? It hasn't really done anything. It's not like you and I are having a conversation right now, and I'm trying to explain the layers of abstraction and computing to you in such a meaningful way. Whereas my computer, all it's done is just sat here and waited for me to do something.
Right?
To it.
Yeah, it's doing nothing until you interact with it, until you tell it what to do. I mean, and then in such, it's not like it intelligently figures out these from the Magic Universe problems. It answers questions that it's already been given. It has answers. If this, then that. Right?
Yes, correct. Correct. You're 100% correct, Jake. So on the other hand, the thing is that humans, and I hate to say it, but humans are actually, compared to computers, are really smart. Meaning we can extrapolate ideas, we can communicate between each other, we can do all this stuff. The only thing that is that we are really slow.
Right.
Humans are really slow when it comes to crunching numbers or doing repetitive tasks or things like that. Whereas computers are really fast. So when you decide to bring those two together, you get something that's just really amazing, you know?
Right.
So just like you said, I mean, you're kind of in this higher level of abstraction, the if-then statements and I'll get to that in a little bit. And I'll also get to what's known as debugging too. You actually introed that in your introduction, but so anyways, back to bits. So there's just like the light switches in the room. So each light switch is a bit. And usually it goes in powers of 2. It can go in 3, but you don't want it to. So if you had 4 light switches in a room, that's 4 bits. The number of different ways you can assign that light switch is 16 different ways. So think of like one on and the rest off, and then the next one on, the second, or the second one on, the first one off.
Gotcha.
Yeah. So it's 2 to the power of n is the formula. Yeah, and you might have seen it just messing around with like Ableton and stuff. Usually the architecture or the bus address for programs like 32-bit, 64-bit,
right,
things like that. That has to do with that.
Right.
So,
Cool. Yeah. Okay. I just jumped the gap there. I feel like.
Cool.
Right.
So let's say you were to walk into this room and you see a row of 64 light switches, and you go, okay, well, I can actually meaningfully turn these light switches on such that I can get a desired effect. Well, one of the cool things is that you can actually assign the furthest row of light switches, or the furthest light switches from the left to be an instruction. So let's say, and it's all, so like, let's say you divide each, these light switches into 8 sort of thing. So if you had one row of light switches does this thing, and another row of light switches is the next bit, the next bit, the next bit. So let's say you wanted to add, 122 to 80 or something like that. Well, you'd actually assign that first row of bits that on the very far left. You can actually say, okay, I want to say that, okay, if you were to say, I want to make the third light switch so it's 0, 1, 0, 0, and then the remaining bits for the number. I want that instruction to be known as add. So then I can have 16 different operations where it's like I want the information that's coming in to do what I want it to do. So I want it to add, or I want it to subtract, or I want it to multiply. I can have 16 instructions doing whatever I want to the following binary numbers.
So you have in these light switches you have at the beginning it's just like an on or off, yes or no.
Yeah. So it works from left to right. It's all separated into eights because
Gotcha.
it's 8 bits, but there's 8 bits is a word. And then 4 bits is a byte,
right?
And then 2 bits. What's less than a byte, Jake?
I don't know.
Okay, so when you take a little bit of a bite, what is that?
A nibble.
It's a nibble. They named it a nibble, dude.
Oh, did they? Those sons of bitches.
Can you?
I didn't actually know that. I was like, well, I don't know what the trick is.
Oh my god.
Yes, that's so epic, dude. Whoever got to that was like, fuck science. Let's make it cute. Okay, yeah.
Anyways.
So I was trying to just visualize the light switches. Yeah. So it's essentially like these light switches do this, but what you're saying is you can program these light switches. You can program the first 8 to say I want it
to add, or I want it to do this.
Yeah. So in order for us to get to the other 56 light switches, if we have 64, the first 8 are now designated to tell the signal what to do as it gets to the other light switches.
Yes, you got it 100%.
Okay,
yep.
Cool.
Okay.
So hopefully people are following along. I think that kind of makes sense. Yeah. That's a good job, man.
So yeah, great job. So you walk into this room and you're like, but that can be, you don't want to just, okay, I want to add 2 numbers, right? I don't want to flip on all these dang light switches.
Right.
Like that just, can I get like a robot or something else to do that for me? And so that's where the next layer of abstraction comes in.
Okay.
So as we're getting higher, we're getting more. What if I were to have like a magic wand that does this for me? And I hate to use a magic wand, but let's say I had.
Would you though?
Yeah, I would love a magic wand. Actually, yeah. But let's say like I had, or let's say I could give it a command that says, okay, well, actually, I want you to move this bit of data into this register and do this and do that and then add them together without having to turn all those damn light switches on. That is actually called assembly. So you're actually moving outside of the hardware side of things, and you're moving into the software side of things, to where that assembly language will allow you to give those commands, or give the command to that first register of light switches to say, okay, I want you to move this, or I want you to add this, or I want you to subtract this. The only bad part about assembly is it still is very tedious and not something that we want to say, okay, move it bit by bit by bit by bit by bit kind of thing. Whereas, or because you literally have to go, okay, I want you to load. In my class, what I've learned is you have to go, okay, I want you to load 0 into the register the first register, and then I want you to then move the value of 2 into that register, and then I want you to load another register, or I want you to load another 0 into another register, and then move that register, or move another number into that register, and then I want you to add these, and then I want you to put it in another register. See how that kind of gets just...
Yeah, it's so many layers. I mean,
Yeah,
you were the way I was visualizing it is actually kind of like a tree. What was the tree you were talking about? Like, just, I mean, even with fractions, where you just
the fractal, or the
I mean, yeah, but if you can think of it like
trees,
if you see it in your mind like that, you visualize it like that. It's just things that seem so in depth, right?
Yeah.
It's kind of a simple task, really, right?
It is a
very simple task.
Very simple task.
So for a computer to get to A, hey computer, get to A to Z, all it has to do is do these quick little trees in its head, you know.
Head, but, so to speak.
Yeah.
So,
right.
But as we're going up, so it even gets even higher than that. So this is where a lot of kids in their computer science program, they actually start in C++, which is the first, or it's not the first. It's called an object-oriented programming language, but it's not the first one. But it's pretty much the main one. It's kind of like I'd like to equate it to like learning piano first. You know how like
getting music theory.
Yeah, if you start on a piano first, it's almost like you can go anywhere. Like I've noticed, like
I hope that's true.
Oh, it is so true. It's so true. I believe it.
Yeah, I mean, I feel like I'm understanding music in rhythm in a new way. I'm talking about this, dude. It's a new language. It's a weird thing. Like the more I learn piano, the more I'm getting like a little progressing in piano.
Nice.
It's hard to put into words because it's not a word language, I suppose. But it's like learning music is just it's a different language for sure.
So as we get into this higher programming language, it's less abstract. So I, as a programmer, could come in and say, okay, I want this program to do exactly this. And then what will happen is when I get everything completely right, when I'm done with it, it will do what's called, it compiles the code. But what it's doing is it's breaking down the code that I just wrote into assembly. And then from assembly, it breaks it down into that machine code for such that the computer can understand it.
Right.
So eventually, as we get even higher, we get into the end result of it, or the highest level of abstraction, which is the user interface. It's such that you or anybody could walk into a room and go, okay, I know exactly what to do here. I know to put a 2 here, put a plus sign and a 2, and then hit go, and it's going to give me the answer of 4.
Right.
So,
or even rather, and tell me if I'm wrong, I might be jumping too far. It's basically when it jumps to user interface, it's basically taking those 64 switches and making it one switch, and all you have to do is walk in and hit the switch.
No.
Okay, all right, back me up then, because I got lost.
So okay, so you're still the 64 light switches are still there. But now there's like it's like a plug-in. It's like you put let's say you put a machine over the top of these 64 light switches, right? And then you can tell that you can then tell that machine, okay, I have these command sets that you can do such that I don't have to go around and turn on all these 64 light switches.
Right.
The machine does it for me. So that those layers are just added on machines to where it will tell the previous or the machine below it, hey, do this.
Right. Yeah. So I think I kind of was right there. So
Yeah,
essentially turning 64 switches into one switch, that part is kind of what it's doing. Not that the human isn't interacting. The human isn't walking in the room at this point.
Right.
This is,
right.
This
Yeah,
is
you're just interacting with it. Yes.
Right. Yeah.
Exactly. So it's boiling it all down to something that you can understand as a human, whereas walking into a room and seeing a wall of 64 light switches is like, what do I do here?
Yeah, where do I start?
So yeah, but anyways, so those are the layers of abstraction that you go through, and a lot of what happens in the C program or C++ to get from to well, how do you get from A to B inside that program? Well, there are different algorithms that you could take, and an algorithm is just an instruction set. It's like if you look on the back of a Nestle Toll House chocolate chip package, it will tell you, okay, you need salt, you need flour, you need all this stuff, and then you do this, and then you do this. Yeah. And then compiling is actually kind of like baking them in a way. If you really think about it.
Right.
So
to get to the final product.
Yeah, to get to the final thing, it compiles. So like baking them would be, but programming everything is making sure that the algorithm is just an instruction set. That's all it is. Right. So when you're going through your instruction set, you have an idea of, okay, well, how do I use combinational logic to get to an end result? And that's kind of right where you were at when you're talking about the scientific method and how you were basically debugging yourself.
Right.
Yeah, and debugging. So what happens when you program something and then you decide it to run, right? It'll actually start at the very beginning of your program source code and go step right through it until it gets to the end, until you tell it to stop, or it ends, or it does something,
or it hits an error before it gets to the end.
Yeah, a semicolon. That's the bane of every programmer's existence. Where's that semicolon at? Anyways, yeah, debugging is just like that. So I can set, I can tell different variables inside that programming code. I can look at them. I can go, okay, I want you to debugging is kind of like a fake run of your program. So you could put certain like pause points in a way. So you put a pause right here on your program and say, okay, at this point in time, what is this variable doing? And you can look at it and you go, okay, well, I see that I put it into a for loop and I got this loop going. It's now the counter's at 6 times I've gone through this loop. So you can say, okay, well, why, if it's saying, if I'm seeing my output and it's getting to 7, well, why is it getting to 7? I can actually put a little stopping point at that and see what exactly it's doing.
Right.
So that's kind of what debugging is. And so that's kind of like what you were saying is, or even the if then statements. So if I see that like the logic I'm getting isn't quite correct, I can go, okay, well, I can step through. There are if then or if else statements in programming to say that, okay, if it is this, then run this code, right? Saying, okay, but if it isn't this, then it needs to do the rest of this code, or it needs to do else if. It's conditional logic is what it is, right? And it have
more than 2 variables there?
It can have anything you want in there.
Oh my god! And oh my god! Like if anything, then anything.
Yeah. Oh yeah. And then there's also there's also things like case breaks. So, it'll check to see, okay, it'll rotate through this thing and it'll say, okay, if it's 0, do this. If it's 1, do this. If it's 2, do this. Or it could be like if the answer is Washington, if it's that, then do this.
Right.
And then there's a default one where it breaks out.
Right.
That's just case breaks and just like stuff like that. But
Yeah, but so even just that there,
Mhm.
that's I mean, it's hard to understand the word simple. It seems a little silly, but in a sense, it is so simple.
it is very simple.
Yeah, it's just you give it an answer or you give it a problem and it says, if I get to this answer, then I know what to do. If I get to this answer, then I know what to do.
But yeah, that's pretty much it. But from the ground up, yeah, you start with your bits, and then even past those bits. So the bits are almost like inputs, right? And then you have logical gates. So there's an AND gate, there's an OR gate, there's XOR, there's in XOR, there's like I think 8 different gates you can do, but these gates build up that what's called the ALU. Let's see what's an ALU. I forget the actual.
We're having Jamie look it up for us. That's Joe Rogan's like homie that works with him, who looks up all his shit on his podcast.
Arithmetic logic unit. So
Okay.
when you build up these gates, you get the ALU, but then after the ALU, you get the actual CPU, the little square thing in the middle of the motherboard. That's their CPU.
Right.
That's the brain of your computer right there. So then after that, you go up into assembly. So that's switching from the hardware side, which is your motherboard, into the software side of things, and then higher than that is the C code and even like dynamic languages that are like scripting programs and stuff like that, or scripting languages, things like that.
Right.
Yeah. But how that so there's that, and then there's actual quantum computers that are kind of weird, right?
Yeah.
So people talk about quantum computers and they're just like, oh god, like that's the end of the world type of thing.
Yeah. What's Rick and Morty's like view on quantum computing? And because I feel like they touch on quantum stuff pretty well. I feel like they lay it out, don't you think? I mean, in like a
like the box thing, like the I'm gonna butcher this, but like the Fleeble box or something like that, where it's like Rick's car dies, and he has to go into the Miniverse. Or something like that.
Yeah, where he dives in and they're like, "You're just my fucking car battery."
Yeah,
yeah,
the Google box or some shit like that.
Yeah.
I don't know, where like he builds a universe inside a battery to tell these people, hey, make free energy for me.
Yeah, and they like have a whole existence. They think they're just like living this whole world.
Peace among worlds.
Yeah.
Rick.
That show's great.
Oh, that show, I'm not going to ruin it, but like that when they get way down in the Teenyverse, so the logic kind of wrote, or the part where Rick talks to Morty, and then their genius scientist talks to Rick the same way Rick talked to Morty.
Oh yeah.
And then there's a little piece that you figure out about Rick, because if it's continued like that, you actually find out a little bit about his backstory about it. So it's kind of there's these parts in Rick and Morty where it's just like, God, that's fucking dark.
That show is deep, dude.
Dude,
that show is
deep.
Layers deep.
Yeah. I think my favorite episode was the Unity episode, because it shows the contrast between science and religion, and how like it combines people, or it makes people like, I'm not going to go there, but it makes people
hey, we can go there on this podcast.
Okay. We can, yeah, I guess, but
you don't have to, though.
It shows how like without religion, people would tear themselves apart over fucking having cone-shaped nipples. Yeah.
yeah.
You know what I mean? So it's like, oh, okay. So I get it. Like that's actually one of the main reasons, or a good reason why religions is.
Well, I mean, humans aren't born with like a value structure in some
Right.
ways. I mean, there is a right and wrong that we feel, but we don't fucking understand it if it's not sharpened. So
Right.
having a structure of values, let's generalize it as that. But yeah,
So okay, but actually, I'm gonna segue this really nicely.
Do it,
So,
do it.
In the time episode, you actually see, Morty. He splits the times like into a bunch of pieces, and they're like on the screen. They're like in their own different universes and stuff. Well, outside of like the garage was a bunch of cats, and it's Schrodinger's cat. Yeah, so it's an allusion to Schrodinger's cat, which kind of brings us back to full circle here about quantum computers. So Schrodinger was this physicist guy.
This is a very famous story. I feel like if you're interested in science or in this world, you've probably heard this term before.
Yeah. So Schrodinger is this guy, or this scientist, physicist, who had this thought experiment that you put this radioactive isotope inside a box, and then you put a cat in it. And the thing is, you close the box, and the part of it is you don't know whether either the cat is alive or the cat is dead, and you don't know whether or not the cat is dead or alive. So when that happens, so it's basically like the cat is this particle, right? It's this photon particle, and it's in what's called superposition, to where we don't know whether or not the cat is alive or dead until we open the box and see this motherfucker's dead.
So though we can assume
alive,
we can assume that he's dead, we actually don't know. It hangs in a 50-50 balance, or what, I mean,
right.
Logically, I guess that's not the right word there, but something.
Yeah. It's in this 50-50 balance of whether it being alive or dead. And that has to do with superposition and entanglement.
Well, wait, hold on. How does this? What was his exact experiment?
Let's see. I'll look it up.
Let's pull up his exact experiment, because that does round it out. It's essentially saying, I remember, as you look this up, I'll say from Silicon Valley, that show, wonderful show. They have a situation where there's essentially they have a live webcam of an eagle's nest or a bird's nest, and they were like waiting for their eggs to hatch or something, essentially. And then one of the characters in the show called in, said, "Hey, I think something's going on. Their eggs haven't hatched." So what they were saying was, and then they had a gentleman come and check on it. He checked on the webcam.
Oh yeah.
And he checked on the eagles. But and then what happened is the gentleman who was checking on this like thing in this forest, he's checking on this bald eagle and the camera, he falls. And then, so what they're saying, how they round about is they're like, well, if you, Jared, who's a character in the story, if you hadn't called about this, then that man wouldn't have been in this situation.
Yeah.
That man wouldn't have fallen to his death, most certainly.
Because he observed it. Yeah.
So it's kind of this whole, it's a, it seems like a small story, but it has this wonderful way to conceptualize a lot of what ifs.
Yeah.
So,
what's free will?
Just kidding. I have a book over there you can borrow.
Oh yeah. Yeah. We'll go into that later if you want to. The Matrix stuff.
Love the Matrix.
Dude, yeah. Well, fuck it. Let's just go into it.
Do it. Wait, hit me with Schrodinger's cat first.
So Wikipedia, I kind of got it right. It's an interpretation of quantum mechanics applied to everyday objects. The scenario presents a hypothetical cat that may simultaneously be both alive and dead, a state known as quantum superposition. As a result of being linked to a random subatomic event that may or may not occur. The thought experiment is also often featured in theoretical discussions of interpretations of quantum mechanics. Let's see. It's just it's observing whether or not the cat's alive or dead. So when we get into when you look at particles, and we split these particles, and I might go into CERN later. I'm not sure. We'll talk about CERN later.
We got plenty of time.
Okay. So, when you split these photons, they are both connected equally. So photons can actually exist two places at once. Crazy, right? But they have really high energy states, is why they can blip in and out of existence real quick, which is fucking weird.
Yeah, we understand that really well.
Yeah. And I'm really trained on classical physics and not quantum physics, so I know enough to get by to swim the waters of quantum physics, but I'm not going to dive deeper than that.
Right. No, and I wouldn't expect you to. I think just like being able to, these words come up so often, and they're going to be more and more in our normal language. You know, we use science and technology more and more. So I think it's cool that you're able to explain it in such that you are.
But entanglement is just this thing where basically when you split these photons, they exist in two places at once. So you can be light years away and these things are still connected somehow. It's crazy. But I mean, it's not crazy because space and time are all connected linearly across the fabric of space. So yeah. Anyways, these particles are tied together, and if you were to observe them, or better yet, like measure them, you don't have to. It's not physically looking at something; it's actually measuring it and saying, okay, this particle is either positive or negative, or.
So this isn't like if I'm just like, hey. Like trying to sneak up on it. Like, hey, I'm looking at you. You know,
you're
like,
not
fucking.
Yeah, you're not going to sneak up on it.
So it's not actually, that. It's measuring it.
It's measuring it. Yeah.
So saying this is this. Yeah. And this is that.
Yeah. Correct. So until you actually measure this thing, it'll. If you measure it and you see, okay, that this photon particle is actually positive, then it collapses that entanglement and says, okay, this particle is positive. Whereas it'll go back. So as soon as So once it's measured, it's done. Its state collapses into that thing. Whereas more photons are out there, and they're in that superposition of either being. It's like a coin. It's like a coin.
Okay.
So think of like you toss a coin up into the air, and you don't know whether it's heads or tails yet, and. It just keeps rotating and rotating and rotating. But until you claps your hands around it,
grab it, stop it,
and look at it, you don't know whether it's heads or tails.
Yeah. It is both heads and tails
at the same time.
And also not heads and not tails.
What the fuck?
Wait, so is that does that ever get into any sort of like, or is that just a quantum statement? That's not the right way to use words. But like instead of it, so it's not just yes and no, but it's also
maybe.
Gosh, man, I'm sorry. That was gonna be some sort of. There was a concept that floated in my mind for a second.
Oh no!
That I was like, this is a middle out algorithm that I thought I was thinking of, but it was probably just.
No, I don't know. If
it
comes back to it, let me know.
If it comes back, I'll try to solve the problem.
But yeah, that's so basically when you split that particle, it has this entanglement to it. And it's in that superposition of being either heads or tails, positive or negative. And until we observe it, it's in that state of superposition. So what does this have to do with quantum computers? Well, we're gonna go back to bits and the light switches, right? So we understand that these light switches are zeros and ones, right? But the problem then becomes, okay, so how do we use that quantum realm to represent these zeros and ones? Well, there's really no way you can. So these people, they built this very elaborate machines called quantum computers, and they use what's called qubits. And these qubits can be in multiple states at once. And they actually use quantum gates like the AND or XOR or those kinds of combinational gates to make the ALU and the CPU. So the problem with quantum computers are really fast. And that's the reason why they're fast, is that they can actually use that the superposition of those qubits to make combinational data possible.
Right.
So the problem that why don't we see, why don't we see quantum laptops? Well, the problem there exists is that we don't necessarily really understand how to use the layers of abstraction, like how I represented it in a normal computer. It can't cross that threshold of going from the hardware side to the software side. Right. And that's why we don't see that, because quantum computers.
It's just a problem with clones, right? This is a huge gap right here. But so clones, we can we can make it'll look exactly like a human. We measured the exact amount of the insides, but how it got there,
Well, I mean, I'm not sure. I'm not sure, to be honest.
Right, yeah, carry on with that one too.
Anyways, where was I at? Let's see. Oh, the layers of abstraction.
Yeah.
So, the quantum computers are designed to do very specific tasks, but do them very quickly, very much more efficiently than a normal computer does. But the layer of abstraction that it has isn't met by, let's say, the computers that we know it to do. So we can't really program this thing. We can only do very low level calculations really fast.
Right.
So that's why I wanted to get into. So I'll make that segue and I'll go into prime numbers. So the problem that we're facing with quantum computers is that the decryption that we use normally is maintained by prime numbers. So what is a prime number? Well, a prime number is something that divides or is divisible by 1 in itself. If you look at 3, 5, 7, 11, 17, things like that, those prime numbers, right? But the thing that they do is they use really, really, really big prime numbers. I'm talking I'll even bring up illegal primes right now, and I'll show you.
Illegal primes?
Yeah, illegal numbers, dude. You can't have this number, or they'll throw you in jail. Isn't that crazy?
That doesn't even make sense.
It doesn't make sense because it's just a number. I can actually think of it right now if I wanted to.
Wait, how would you get thrown in jail?
Yeah, I'll get to that in a minute.
What?
So yeah, I know, dude.
They can't own that shit. Or is it the nuclear codes? You get the nuclear codes, bro.
No,
You're
it's
too
not.
close to the numbers.
It's not nuclear codes. But yeah, so you look at this number, and it's just this huge ass number.
Legal prime number. So you can just search. So people can just search. Is this what would you search on Reddit? Just a legal prime number?
Reddit. But see, actually, this is actually a good one too, because it'll actually go into kind of what I'm going to talk about here in a minute.
Oh, in the comments they do?
Yeah,
in
the comments.
Yeah. So if you want to check along, friend, just Google Reddit illegal prime number. Let's see what pops up. Carry on.
And I don't think that this is actually a prime number. I think somewhere in the sequence, or no, it's a zip file that can lead to it, is what it is. But I don't think that this is actually it, because I think somewhere in that sequence they changed one number.
Right.
So that's crazy, right? It's that one number makes it from prime to not prime. It's weird. But
so what if you were looking at that right there and it had the correct number in it?
I think the FBI would actually contact this person at some point and be like, "Yo, take that down."
That's fucking crazy.
So here's the crazy thing: is why is this thing so illegal? So, when you're using decryption, there's what's called public keys. So let's say you log into your bank account. Your bank account sends a key that has a one huge ass prime number in it. And I think banking keys or something. They have a allotted amount of keys that banks can use or prime number keys that people can use to access their shit. But they want it to do is they want it to match or if I got it right, so it's a handshake, right? It's It's you saying, okay, I got all my login information. I want to make sure this is secure. So they use that prime number to say, okay, this is actually the right thing. We're good. This guy's good. So the problem is that when you're trying, like hackers, right? When they're trying to figure out, okay, I want to figure out what this guy's banking thing is, right? So I want to figure out, okay, I can factor big numbers, right? And they use prime numbers for a reason, because it's only divisible by 1 in itself. So they use a prime number because it'll sit there and it'll go, okay, a computer can factorize the number 1,000,000 into all its different factors really quickly. But it does that by guessing and checking and saying, okay, I got all the factors, boom, I'm good. But
Right.
if you have a big number like that, it goes, fuck, I gotta check all these, and I gotta make sure that this comes out right. And it sits there and it sits and spins and spins and spins its gears and goes, and it just takes forever for it to compute. And eventually, I mean, if you give it enough time, it'll spit you out something. But the key is not, I mean, we're human. We don't got all that.
Right.
Anyone don't got time for that.
Yeah.
Anyways.
Nobody got time for that.
So they use prime numbers but the problem is the quantum computers will be able to say, fuck that, we got it, like quick, like
Instantly.
Yeah, instantly. So that's the main issue between, but the other thing is also the abstraction levels to it too. So anyways, that's how prime numbers comes into play. But the coolest thing, the reason why those prime numbers are illegal is, I think back in the day, and, it's actually in that Reddit thread. Back in the day, this DVD pirating was huge. It still is huge. But what the DVD company decided to do is put a
Encryption key.
Yeah, they decided to put that encryption key on it so that people couldn't just rip off their stuff just like that, So I think someone somewhere figured out that it was this illegal prime number. And what they did was they sold they went to a company, they go, "Hey, I didn't know the encryption key to this."
Right.
So what they did was this company was like, "Okay, well, we'll pay you for this, and we'll use this encryption key inside of our devices that will allow you to bust open this DVD and then pirate it or upload it to the web so people can pirate it."
Right.
I mean, it's brilliant, right? Well, the FCC was like, "Fuck that! You can't do that. Like, we're gonna throw you in jail." But having that encryption key or having these illegal prime numbers, because the company had it, they undoubtedly had it. Like, you can crack open their device that strips the information inside the DVD, and it was there. It was broad as day. Like, you're fucked. Had them dead to rights, yeah.
So that's good. Just looping that to the ingredients thing. So that's like knowing, like, so if the back of your thing says flour, apples, and cornstarch, and that's what makes it. It tells you exactly how much flour. It tells you exactly how much cornstarch. It tells you the ingredients, not just the ingredients.
Oh, yeah.
But how it fucking works
It's
together.
like having the secret ingredient. It's like
having secret.
yeah, it's dude.
It's kind of like having the well, I guess not a super tone, but I was thinking about, like, also that, kings back in the day that have like their official stamp.
Oh yeah.
Like, if you open, like, this is from me and
Yeah.
only me, and like,
Yeah.
there's nobody else who
on
has
the ring
this.
and shit. Yeah.
Yeah. I forget what the heck that's called. Why am I?
What is that called?
Oh man, I totally, this is like my favorite terminology world over here. I should know this.
Okay.
Or maybe it's not even a cool name, but
Yeah, it is like that. It's like having that. It's having that special stamp or a special ingredient that says that you don't include. It's like KFC. You don't. What's the secret herbs and spices? Like.
can't give them all the juice, man. They'll steal your business model.
Maybe there is no secret ingredient. Kung Fu Panda. Boom.
Yo, that's such a good movie.
A great movie.
That's such
I
a good movie.
actually just watched that like the other day.
No shit.
Yeah.
Shaylee and I just watched it in London like 2 months ago.
No way.
Yeah. I noticed, I mentioned that I was in London. Like, I just want people to know that I was in London.
Dude,
I'm going to watch it anyway.
How funny would it be? So, like, how in movies, how they'll get like actors or voice actors to redub the actual thing. But
Okay, yeah.
imagine it being so. I mean, Kung Fu Panda is in English, obviously, but imagine if it was like in like Cockney, like English.
Oh, mate.
Oh, there ain't no secret ingredient.
Ain't no secret, you fucking yank. All right. Hey, fuck off once you use a secret ingredient, mate. Fuck off, eh? I don't know.
Oh God.
Okay. Hey, you know what I do want to talk about? Also more Cockney thug. Wait, okay. I did go to this. I always just want to mention this. I went to this pub, Shay and I, and it was a Cockney, I don't know what he called him. Cockney singer. He was a Cockney pub performer.
Yeah.
But oh, dude, it was so great. It was just, you go into this small pub and we were super hungry, so we ate. We were like the people who were eating, and you probably shouldn't eat, but everybody just singing along. They have their pints. Like, people are just like spilling their beer all over. It's like this fun, like everybody's singing, and he's just in the corner with a curled mustache singing like cool Irish songs and cool, British songs, that London songs that I don't know. But
500-year-old pub song.
Yeah, dude, and it was just so fun. It was so fun. I love mentioning that because you just the Cockney pub thing. But I do want to talk about something that we touched on right before this was the coolness, real quick, because it equates to kind of where we just were with the quantum computing.
Yeah.
Recently, this is not meant to be a scary thing, but recently Google they've got their version of the Summit computer, the quantum computing.
Oh, yeah.
So there's a football size. So here's the way that I know it, and please correct me if I'm wrong. There's a football size computer. I think it's in California, Summit. It might not be in California, but it's football size computers. It's racks of computers inside a warehouse or whatever that are just solving problems. It's just solving the fucking problem of problems. The problems that you don't know exist or think that we need to know, it's looking those up and it's trying to figure them out and whatever. That's my understanding. So in what Google now has is recently, within the last couple of months, we thought this was like 10 years out or something, but they achieved the fridge size version of that exact same thing.
Jesus.
Yeah.
That's scary.
Yeah.
That is so scary.
Fucking hell. I mean, and again, they did say, they're like, oh, and it's 100 times faster. They said that too, which is creepy. But I don't know if I don't think these things equate across the board as much as they like in conversation, they simply like relate like, oh, it's the exact same thing as the football field, but smaller. Like, I don't think it's that simple, but
not quite.
Quantum computing is a very interesting thing.
But still, supercomputers are still different from quantum computers. I mean,
supercomputers.
But so supercomputers are still a computer that is still going off zeros and ones. It's not going off of qubits or anything like that. But it is very, 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 very.
So the supercomputer hasn't even jumped into quantum computing.
Well, think of like quantum computers as something people use as they use quantum computing as for very specific things. Like, even though these supercomputers could actually now do the same processes, it all has to do with what you're really trying to. So the problems so it really depends on what you want to try to do. So if you want to like map genomes and stuff like that, I mean, you'd almost want to use a supercomputer to do that because you're looking at mounds and mounds of data. Like, so you want to sift through that and look for things, or whereas quantum computing, it will do different things much quicker because it doesn't have to rely on zeros and ones. It's that superposition that it's relying on.
Right.
So now it's actually so even scarier. So I think supercomputers run off of what are called flops. So it used to be called MIPS. That would millions of something per second. But it's actually starting to get into what's called exascale, and it refers to computing systems capable of at least one exaflop or a billion quintillion, or it's a billion is a quintillion calculations per second. A billion, Jake, per second.
Our brains don't even. Our brains think that we're like, yeah, I get that. Your
Yeah.
brains don't get that. It's just like the population of the world. We're like, yeah, we know what's 7.6 billion people. That's this many people. Our brains don't understand that number.
But
Also, MIPS is a cute word for something.
Yeah.
MIP. I want to name a cat MIP.
MIPS. Yeah.
Mips.
Oh, dude,
Mips.
Mipsy.
Oh, that's kind of cute. I don't know. Actually, no, I don't really want a cat.
Yeah, it's nuts because we're starting to get into when you have that crazy or that amount of calculations per second, you're starting to get into the capacity of a neural or what our brains could actually do, because our brains are still really, really fucking powerful.
Oh yeah.
Like but it's just weird because we're now starting to really get into that threshold of holy shit, like we're starting to we will, I mean, I almost think that we will see what is called the singularity in our lifetime, Jake. It's gonna be,
I think so too, actually.
And it's not a matter of if, it's a matter of when. And
yeah,
I think it's dude, we'll see it.
There's so many things that, like, I think, like you think you're like, oh, here's how we're gonna get there, and here's how that's gonna happen. But I feel like it's gonna be like when we reach the singularity, like whatever the fuck that really means, even.
Yeah.
Like how it's going to happen, how we're going to get there, and like when, and the time frame. Like it's gonna be so far fetched. We're gonna be like, it's something we can't even think about right now.
No,
it's gonna be a whole different language.
So going into that, when people talk about AI, they're most talking about what's called narrow. There's two branches of AI. There's the ones that we know, Alexa, Siri, things like that. And then that's the narrow AI. And then there's the broad AI, which is the spooky one. And the spooky one is something that is the singularity. It will happen, I hope, in our lifetime. I know it's kind of messed up to say that I want to see it in our lifetime, but because it is scary. I mean, you got people like Elon Musk saying it's like summoning a demon, and it really is like summoning a demon.
There's a lot of people who think it's exactly summoning a demon,
and it could spell disaster for humans. Just not. Yeah.
I think there's a lot of blind optimism about it, but I also think that, like, we're right to be scared,
right?
But we can't stop progressing. It's this weird. I don't know. I mean, I'm not even at any, like, I'm not piloting any ships towards this harbor by any means. You know, I'm not solving any of these quantum things myself. So
no.
I don't know. It's all different worlds, but it's going to change a lot of the way we do a lot of things.
Yeah. And you put, so, I mean, I hope all of you listeners have watched The Mandalorian. And if you haven't, I'll try and not ruin it, but
you know what? Actually, let's just so you have an open platform. Let's just say right here, if you have not seen The Mandalorian on the Disney Go app, Disney Plus, we are going to have some spoilers here. It's a wonderful show. We won't ruin it, even if we talked about things. It's definitely worth watching. It's super fucking good. So go ahead.
The Mando, he shows up to this guy. His name is Quill, or his name's Quill, right? Quill, something like that. He's a farmer. He helps. So the Mando helps the farmer out by getting rid of these thugs in the base, and they kind of spark a friendship, and he's like kind of like the only guy he can trust. And in the beginning of the series, there's other bounty hunter going after Baby Yoda is an IG droid, and it's just this thug killer dude goes in and wrecks these fools.
Yeah,
it's awesome. And then so this IG droid was like, well, fuck this, I'm gonna kill this Baby Yoda, and Mando was like, fuck that, I like the Baby Yoda. Fucking shoots the IG droid in the head.
Yep.
Fucking dope, right? So being as resourceful as this Quill guy is, after the Mando leaves, this Quill guy picks up the IG droid and programs it to and then I looked into the background of IG droids. Apparently, like, these things were like, as soon as they turned them on, They destroyed all the research scientists.
Right.
Yeah.
They just follow orders.
They just follow the orders.
They do what they are told as a robot. So yeah, and I remember Mando had shot him. It was like a very big like blaster shot to the head. It fucked up his thing, and they made it clear that like this droid is toast. He's done. He's decommissioned.
So how does this all apply? Well, the Mando got into some trouble, and he came back to Quill and was like, "Yo." And the Mando, he doesn't trust droids. It's obvious he doesn't trust droids. He doesn't like droids. No. And he comes back to it, or Quill, and the next thing he sees is that here's this IG droid back in action, and he's like, "What the hell?"
Yeah, this
thing's a ruthless killer. It's designed to kill the Baby Yoda. Like I don't like it. Like F that. Like no way. He's like, whoa. He's like, look. I brought it back to my workshop. I reprogrammed it to do this. I can reprogram it to be a nurse droid. Mm-hmm. Like it will serve me. And it shows a whole cutscene of Quill teaching this IG droid to do certain things.
And it's a warm scene too. They give you this like, okay, we trust Quill. Mm-hmm. Like they give you this like, we understand Mando, our character here, but we trust Quill with this. Like, oh, he changed this droid.
Yeah, he changed this ruthless killer droid into a functioning, serving thing to operate and to work with him instead of against him. So immediately I thought in the back of my head, like, oh my God, that is such a reference to like how people look at AI. And he goes, look, like it's the programmer who programs this machine to do the things that it needs to. If it's programmed to kill, it will kill. If it's programmed to serve you and to be kind and to do these things, it will do that. And so when we think about like the broad AI and people have just doomsday thing, and it's not until it can be like that, and it might be like that. I'm not sure, but if we put in measures in place to where we see that, okay, like we and it's tough because we say that it's AI, right? But if we control it, it's not really AI. So what measures can we put in place to make sure that it doesn't just end up destroying us? Because if we go, okay, I want you to take control of stock markets or whatever is designed to do. How could, if at one point it decides, okay, well, and it could be just this most subtle little, snowball effect on something like, oh, well, humans are now doing this. Now I have to protect what is I'm designed for, is to make sure that the system stays in place and is balanced, and does if I'm threatened, then I have to take care of the problem, which is humans. That's where it gets fucked up. That's where it can spell destruction.
So if you give it this is oversimplified, you give it a task, open all the Coca-Cola bottles in the world.
Yeah.
Like do that in the fastest way possible. Go right now. You give it a task. You're a human. You type, you say, this is what you do, droid, go. Droid goes, but the fastest way to do it, because you said the fastest without these, some variables, some laws, let's say robot laws, it's okay. The fastest way to do it is to kill all humans real quick and use their fingernails to throw throw at the top of all the Pepsi cans or whatever I just said, Coca-Cola cans, the bottles. It will find the shortest distance, and it's kind of cutting corners essentially.
Not having any kind of, well, actually what I should do is just gather all the Coca-Cola cans and just pop them off and just. It doesn't do that. Yeah.
Right, yeah. It's like you said the fastest.
Yeah.
What's the fastest?
Yeah. It's like, what's that? I still can't think of it. We talked about it, but it's like malicious. I almost got half of it. It's malicious compliance is what it's called.
Malicious compliance.
Malicious compliance. It's like, it's kind of like your mom telling you to clean your room and then moving everything outside of your room such that there's nothing inside of it.
Right. Yeah. Like it's clean.
It's clean.
It's clean. There's nothing in there. I cleaned it of all the bed and the TV and everything. That's a great example of malicious compliance.
Yeah, it's very,
because that kind of lays out like it will find the smallest thing. I think that I heard one thing,
but it's not malicious. It's just them making the connection.
Right. Yeah. So that's the thing is, I think that, as a basic human understanding, a lot of times we, I don't know this for sure, but we might see it as like, oh, well, it's gonna get human emotions and do things maliciously.
Yeah.
Like no, it's not actually doing things maliciously. It's not like it picks up the evil from the person who programmed it. It's just the person who programmed it told it to do these things, and if they didn't have the right checks and balances, it's going to be contributed as something evil. Yeah. It might kill people, but
that IG droid still went into that base and marked fools, but.
Wait, what was the part where he so again, spoiler, Mandalorian, the part in the end where the droid, they were in the boat, like was it a lava boat or was it?
Yeah, it's a lava boat.
So remember at the end that was an argument. That's a good example of his programming actually, which an interesting example because I don't think what he was doing in this scene, I don't think we're at yet, right? Technology wise, I don't think.
Yeah, it gave the Mando so should I resort back to my old programming or do you want me to just keep going?
Yeah. So
I don't know, something like that, but
yeah, it was essentially saying like my what's the most viable option to keep my main programming, like keep Baby Yoda alive. What's going to be the sacrificing myself as a droid is the most plausible outcome to keep this Baby Yoda alive. I think it was like that, right?
But I can't do it unless I'm told to resort back to my main programming.
Right.
Crazy. God, that's
so weird.
Yeah, dude. But yeah, that just like that jogged the back of my head. I was like, that has everything to do with like what's gonna happen in the next how many ever years. And it's we're gonna, I hope to see it, but we definitely have to put protocols and things in place. And I don't know if that means augmenting humans with machines, because it might be that, or it might be something else. I don't know. I haven't gone that far in my science career, but I'm pretty far, but I haven't gotten that far.
What is your what are your classes? I think I asked you last one, but what are your classes you've taken? Obviously C++ programming.
Oh, dude, I've taken. Oh my god. Okay, so like just
lay them out.
Okay, all of them, or just computers?
Whatever's relevant.
Okay, so I had to take 3/4 of engineering physics, which is just going over the classical physics. I started at I started at trig. I placed into trig, and then moved up to pre-calc, and then from those calculuses I made it through calc 4, and then past calc 4 I've done linear algebra and differential equations. For computing I've done C++ is what they start you at. It's basically learning piano for the rest of the computer languages. Right. And then you go in. Well, I've also done discrete math, which is learning about like number theory and number sets, and like how there's more than one infinite. There's like so there's a set of all numbers, right? Like normal numbers, 1, 2, 3, 4, 5. But how many numbers are in between? How many numbers are in between 1 and 2? There's an infinite set of numbers between 1 and 2. And that's a different infinite, or the numbers of all of those numbers inside that numbers is a different infinite.
What was the name of that class?
Discrete math.
Discrete math. Yeah. Like whatever strange concept.
That's the one where it's like it gets into weird symbols. I'll show you. It gets into like,
how was that class? Was that?
Oh, it was awesome.
Was it interesting?
I loved it because it's like the guy who taught it. His name is Nick Macias. He's a bit of a unicorn down there at Clark. I don't know why the guy's teaching. He's just this. He's the kind of guy where you can tell, because you know how, if you ever watch the Joe Rogan thing, you see how like Elon sit there and he'll like, you can see that, you can just tell the gears.
Oh my God.
Are moving a mile a minute.
I think he has 17 layers deeper than a lot of us can hold.
Dude, for real.
Some of us do it different, depending on your, I don't know, intellectual ability. You can hold you can hold layers, you know, like there's,
Yeah.
you can kind of get to notice how many layers deep you can hold a concept and be able to come back to the original concept. But dude, that guy fucking holds 17 layers deeper than anybody. It's wild.
And this guy, this Nick Macias guy, he could just, you would ask him a question and he was already like, and the crazy part is that he wouldn't necessarily look at you straight in the eye.
Mm-hmm.
I don't know if that's just like who he is or just what it is, but you can just tell like the gears in that guy's head are moving.
Right.
And I don't know why he was teaching it, but he taught it in such a way. It was really cool. It was like the logical part of it was, you know, if you see water on the ground, you know, does it mean it's raining? That was one of the questions that got brought up. If there's water, if you walk outside and there's water on the ground, does it mean it's raining? I mean, someone could be on the roof with a hose. Someone could be up there pissing on you. It just depends.
You could be next to a spring.
Yeah.
You could have your pipes just broke 10 layers deep.
Yeah, exactly.
There could be so many things.
Someone could went out there with a bucket and just, I don't know. But it's learning that logic system. It's so if I said A plus not B, what does that equal?
A.
Yeah, thank you. You got it. Great. That's exactly it. But it gets much harder than that.
Right. Yeah. I mean, and think about telling like, all right, mm-hmm. computer, mm-hmm. who is just ones and zeros or whatever it is. Like what? Yeah. You learn this.
Yes.
Oh,
exactly.
Dude, math is so crazy. Nuts. But it's great. It's cool to think like, you know, just what I said at the beginning, relating that back to like problem solving.
Yep.
It seems like this thing that's science seems like this out of reach thing. Or something that's like, oh, it's not like my interest, or it's not like my. I mean, obviously, it's all over in your life, and you know, I love science too, but I love emphasizing to the regular people that like, dude, like the way that science is done is how like humans work backwards. Like you figure yourself out.
Oh, perfect,
like, dude. It's
perfect, dude. You got that so right.
So great. I love it.
So let me ask you this. Or here's another question from that guy or Nick Macias, and that he's a professor at Clark. One of the things he brings up is it's called mathematical induction is the coin term of it. But the question is, if you were to walk from Seattle to Boston, how would you do it? And you have to walk.
Okay.
It's not a trick question.
I suppose I would just plot the shortest distance, the quickest distance from here to there.
Yeah, but how are you going to do that?
Start walking.
Yes. That's it. You can get from Seattle to Boston. All you have to do is put one foot in front of the other. That's induction. And it goes way deeper than that because you have to prove it. And discrete math is doing that. It's okay, prove that this number is even. And it's, is it divisible by 2? If it is, then yes, it is even. If it's odd, it's 2n plus 1. So it's shit like that. Is
discrete math definitive in all cases, or is discrete math something that you could just keep taking semesters and quarters of discrete math and learning different layers and layers?
Oh no, it's just that one layer. I promise. Okay. It's not like calculus.
Okay, calculus. Because on the surface right now, I'm thinking that it just complicates everything times.
No. It's learning. It's just number theory and learning how these numbers interact with each other. But the main point of it is, yes, you can get from Seattle to Boston, but how do you prove that? And it's learning. Okay, well, there is a road structure. There is a path to get there. And it's all it literally is putting one foot in front of the other. And it's there's no thing in the middle where it's like, haha, like you get to Missouri and you're like, there's no roads anymore. You're fucked. So, but yeah, anyways, that's discrete math.
Okay.
I don't know where we were going with that, but
I don't know. I think we took a side street. I was asking you about the classes that you took. And then I asked you to expand on discrete math, I think.
Oh, yeah. So I took discrete.
What was your, out of these, definitely list off if you have more, because I think you definitely do, but if you can remember, what was your like funnest, or I mean also like funnest professor too? I always like pointing out like the not to like just make one person famous or make them like, but there is something about pointing out someone's like name, like this person was a good professor because of this.
Yeah,
I always love doing that,
I mean, besides the core classes like English and stuff like that, like within the actual core of the engineering degree, I mean, I'd definitely say that Nick, he's just he reminds me kind of like a lot about like you. He was very eclectic in his choice of like suits that he wore. Like he almost rivaled like the crazy guy with the question mark suits and stuff. Dude, it was crazy. He would wear like those feather earrings that you have.
Excellent.
Yeah, I know, right? You would fucking click with this guy. So
dude,
yeah,
awesome.
You would love him.
Let's do it. Sometimes I daydream like maybe the podcast will open up these cool relationships with these like professors.
You never
like,
know. You never know.
Don't know, man.
But very eclectic guy. Had just a beautiful way of explaining things, and I wish I could just follow whatever he had to say. But it was really cool because I think he really liked. I had to do a special project board about something. It had to do with music, and I think I wanted to build a board that allowed me to connect to I think Tractor, and somehow program Tractor to that little breadboard, just to do simple stuff, not crazy shit, just simple like
hit play.
Yeah, exactly.
Yeah.
And he was just like, "Oh, that's really cool." Like what? Like, and he, of course, this guy, mile a minute, right, was already like on my shit about like, "Oh, you need to do this. You need to do this. You need to do this."
He's 10 layers deep of how
10
you can
layers
solve
deep, and I'm like, dude, I'm trying to figure this out myself. Like. So it's just that, yeah, he was probably one of my favorites. But yeah, I've taken C++, and then from C++ you go to Java, which is a different object-oriented programming language. And then from Java, you go to you keep programming in C, but you go into what's called data structures, and you're learning how different algorithms will affect data differently. And then you get higher. I went into CS285, which is then going into a program language called C. So clever play on words. So C programming language came before C++. So in a what's called a for loop, you assign an integer, and you decide A is equal to 0, and if it's less than, let's say, 9. You're going to increase A, and then you'll execute some code. So let's say inside that code, it says your number is, right? So you go through that code. You start with the first one, right? It starts with 0. A equals 0. And then it goes, okay, I'm done with the loop. I'll start back over the loop. And I go, okay, now A is 1. And then it goes in through the loop. It says, okay, your number A is now equal to 1. Does it again. A is 2, A is 3, A is 4, A is 5, A is 6, 7, 8, 9. And then it gets to 9, and then it's done with the loop, and it goes out. So what you do to tell A to increase is you go plus plus on the source code. So the funny the funny programming humor is C came before C++ because it's the next iteration of C code. Funny, right? Okay, yeah, dumb programming humor. Oh, that's a forced laugh. Stupid Kelly.
No, I mean, I wasn't laughing at the subject.
No. Anyways, So how did learning C was tough because C is not like C++, where it can be object oriented, but it's not. It's just we use what's called pointers, and these pointers are used to reference data inside an address. So we can pull and manipulate things using these pointers. But for some reason, in C, they decided that like these pointers mean fucking like every different thing ever, and it's it was built for masochists, basically. It was just terrible. I don't know. It was just so fucking hard to.
But it's a step that you have to like learn along the way.
Because it's so important because your MacBook is a Linux based, so it runs C code. A lot of the Linux systems, like almost like majority of what we use in this world is Linux based. Like even that supercomputer, that Summit supercomputer is ran off of Linux. Can you believe that?
That's so weird.
Crazy, right? So are we good on time?
We're good on time. What's I mean, we could give it 15, 20 more minutes. You want to do that?
Yeah. So
10, 15 or something.
I think I'm at the end of kind of what I kind of wanted to talk about.
I feel like we kind of like touched a good basis. Let's just like chill on it. Do you remember what got you into like science, math? Like, is there any like whether it was childhood or teenagers or anything that like kept you hooked? Do you remember?
I felt like I was always good. I always felt like I was okay with math. Like I never like, I mean, of course I wasn't the kid that like, I say that I am, but I was never the kid that got done first with those multiplication tables back in like grade school. Yeah. Like you would slam just to make people know that you were done first. Like slam that motherfucker.
You're like, I didn't do the last 37, but I'm done first, bitches.
Anyways, I think well at a very young age, I've always liked space. I've always wanted to be an astronaut. And if you know me, I'm very well connected to the spaceman.
The spaceman.
I am the spaceman. And I think like when I was in like 4th grade, I did my science project on the Mars rover.
Ooh.
Yeah, dude.
Sick.
Yeah. And so I became a little Elon Musk like follower at that point in time because I'm like, yeah, we're gonna go.
You were just investing in PayPal.
Yeah, dude. yeah, exactly. Mom. I need PayPal.
He's wicked smart.
But no, I've always I mean I still want to be a fucking astronaut, man. Fuck. But never lose your dinosaur, right? Like fuck.
Hell no, bro. I mean, I don't really know how it's going to work out, but we are doing some interesting stuff with the moon and with space. Space is going to be a pretty open thing in I think 10 years.
China's going back to the moon. Can you believe that?
It's
50,
so cool.
50 years later, we're going back there, man.
It rips open this whole new like weird world. It's exciting, but it's cool that we're going back.
I think the next thing that actually got me into computers. So you can actually you can take a milk carton. Yeah, you can take a milk carton and it can becomes this computer where it has like flashcards. And I think what you do is you pick up the flashcard, and it like goes into the milk carton, and it flips the card around. Is basically what it does because the answer's on the back. So you have a 5x5 or the 5x3 note card with a question in front of it, and then you put it in the computer, and the computer spits it back to you, and then you read it to them. So so. I think like just that's exactly where I was like, fuck, I love technology. Technology's cool. Like I want to do this. Like, but as I went along, like I got through high school and I became a very active DECA member. I think that's initially where I met you and Gunner both. Right. Like met you both trying to recruit you guys into DECA, and I'm glad it did. Shout
out DECA, dude.
Dude. DECA's
blessed from that opportunity. That's a great. I think anybody, dude. It's like one of the more important things. I think like anybody, if you can get your little sister, little brother listener into DECA, if they're in high school, marketing program, it gives you great interview experience, a lot of mock like interviews and stuff. Lots of great stuff. But.
Dude, it's so crazy too, because like Rick Davis, shout out Rick Davis, you're the man. I feel very blessed to have been under his era of DECA. Amen. But crazy enough, like I was doing a wedding this summer, and I met one of the new instructor for that class. I go,
no shit.
And I don't know like how it came up, or like I don't know if I just asked, what do you do? Like just being nice, Kels, like
pop that.
Hey, what do you? Oh, I'm the new marketing director or instructor for Kelso High School.
Mm-hmm.
No shit. You
Right.
don't say.
Wow.
And so,
Like, what? I mean, that's some shoes to fill.
yeah, that is some. I was like,
Yeah.
dude, the exact same words. I was like, dude, get some shoes to fill, man. Like,
They're probably sick of hearing that, to be
Oh,
honest,
yeah.
though. Damn. I didn't think about that. It's like a short joke, right?
yeah,
Like,
yeah. Yeah, I got into DECA, and I was thinking, oh yeah, I'm just gonna be a business guy. I'm gonna be a business guy, and dude, I can't sell shit. I'm the worst. I am the fucking worst salesman ever. Like, I can't do anything. I'm not, shout out like the Justin Laphams of the world who can just hustle,
right,
dude.
Yeah.
I love that guy because
Yeah.
he can just hustle. That is not my forte. I
Right.
like pushing numbers, and so that I was like, well, maybe it got me thinking. I was like, I like numbers. I've always liked numbers. I don't know why. Like, I was never really good at math in high school, but I've always liked numbers. So I still like business and I still like numbers. So I'll get into accounting, and then I quickly found out with accounting that accounting is just the same shit over and over. Sorry to any of my accounting majors. I love you guys. What you guys do is very important. It really is.
Dude,
But
I couldn't work at a bank.
The chemistry is not there
Yeah.
for Kels. It's not there.
Well, hey, you tested the waters. It wasn't for you.
I'm a problem solver, dude. That is one of my fortes. Is I can look at things and go, I need this, I need this, I need this, and we're gonna make this all stitched together,
Right.
and we're gonna come up with a solution. And that's what I do best.
Yes.
That is seriously what I do best. And
Accounting is plugging numbers, kind of, right?
accounting's
I mean, not
balance.
to simplify it, their whole job. Just to
No,
numbers,
it's not just plugging in numbers. It's balancing the books. It's creating ledgers. It's all that kind of stuff. Whereas, and it hasn't changed. The practice of accounting has not changed since the Roman era. It has not changed. I swear to God.
So you didn't do DECA, or you didn't do salesman.
Yeah.
You decided that was just like,
Yeah. But then, okay, so my buddy, shout out my buddy Evan Anderson, who I met up in Bellingham. He and I worked together at Lowe's. He was in the lumber area, and I was in the paint desk. And I think we became friends through music, obviously. Like, we both really liked heavy metal and shit and
excellent.
all that stuff. And Evan was in the computer science program, and he was his senior year, and he was on his way out. And I think we were just like fucking both drunk one night, and Evan goes, dude, why don't you fucking do this shit? Like, you seem like you got like such a knack at it. Like, why don't you do this with me? Like, you say you don't like your fucking major right now, dude. Fucking switch that shit up, man.
Right.
He was like, dude, I think you'd be fucking great at this.
That's
really
epic.
Yeah.
Yeah.
And I just go, fuck, Evan, you're just so fucking smart, dude. He's like, dude, it doesn't have anything to fucking do with that.
Right.
He's like, you're more than fucking capable, Kelly.
Right.
And I have to say this with people is whenever I bring up what I'm doing, and I hate when people get discouraged. I hate it. I hate when people look at math and they just go, fuck this shit, dude.
Yeah. It's a million steps. They don't see the one staircase, the one step.
Yeah.
They just see the million steps. They don't want to do it.
Once you, like, I've climbed the mountain, dude. I'm not a whole, like, there's still some shit that's out there that's just
Plenty, yeah.
like I won't probably touch on because I just don't need. I do want to get my minor in mathematics, and there's like analysis and stuff, like a couple other stuff that I want to take before I'm like I cash out. I'm done. But for the most part, I've climbed the mountain, dude. I've done every branch of mathematics possible, and it's beautiful. At the top, it's just you look up and you turn back. It's so beautiful how the world and the universe works, and it's so like, yeah. I think I went to like I went to Office Max one day, and I was like, I need a calculator because I think my TAA 3 was fucking up on me or something like that, and I just needed just a simple calculator. And here's the weird thing about calculus is that you don't need like some crazy ass TIA theory. All you need is like a little punch number calculator. That's it. I think I needed something that could compute like angles of sine. So there's sine and cosine, shit, tangent and shit like that. And I needed to figure out how the angle of shit. I don't know what I was doing at the time, but I was like, fuck, dude, like, do you realize that you can unlock the universe with this little fucking thing?
Dude.
If you understand,
those answers fit into other places.
They do.
That's so crazy.
Fuck, that's right. But yeah, it's the truth. It is the fucking truth. And it's like this little $10 thing. If you know how it works, it unlocks everything.
Yeah.
Everything. Nuts, dude.
It's fascinating. I always love that. I've mentioned that on this podcast before, that I think mathematics is exactly that, beautiful. I think mathematics is beautiful. The cool thing about me is, like, I mean, we've been friends for a long time. You know, I don't know a ton about math. It interests me. I love it. I think it's fascinating. I love to learn about it. I'm kind of like, I love to learn a little bit about everything, you know, of course.
Yeah,
but
of course.
But it's funny, growing up, I always had that I'm not good at math. I'll write a mean paper. I'll read anything you need me to out loud. I'm great at all that stuff. But when it comes to math and chemistry got thrown into that math thing too, because I hit a point in chemistry where I was like, I stopped understanding the stage before this fully. And now that I've gone to the other stages, I can't understand any of what they're saying. Yeah. And so I was like, well, that's math too. That all sucks. But now that I'm older, I learn little bits and pieces, and like you and I always have good conversations. You teach me a ton just by us being our friendship. Oh yeah. But like, it excites me to think genuinely, like later in my life when I have, like, let's say some free time, like what's a subject I want to dive into? You know, I've got a lot that I'd like to dive into, but I'm literally like, later in life, I'm definitely going to spend, maybe a year or two on just learning more math. I'm so excited about that. I think it's such a beautiful, wonderful thing. I think, again, that like just you just said, it's not daunting. It's not, big picture. It's a ton, right? But the first step, if you're just like, this is interesting. Science is interesting. Math is interesting. Physics, interesting. Like you can take a little step and you can flirt with it and you can learn a little bit. Yeah.
And it becomes like, I think I got to a lot of these higher level math classes. They have this aha moment where you're like, you're fighting with it. And you're like, God, like this doesn't make sense. Like, and so your brain's a muscle, right? You have to give it time to let shit sink in and think about it and sleep on it and then come back to it and be like, oh yeah, yes. Dude,
I love that.
And then finally, I think it was differential equations, which is fucking god awful. It's just but it was at one point in time. I mean, for me, obviously, for those level of classes, it's not that. I think Calc 4 was a little bit harder for me because it was just coming back to all the things that I've done previously. But I'm usually good at something isn't hard for me until like I have to. As long as I give something time and space, and to just kind of let that kind of sink in and do its thing and work on it, I can get it right. And finally, at some point in that differentials class, everything just started falling in together. Like all of these pieces that we were learning about it just all fell in so beautifully together. And like, I was just like, I fucking love math. I love it. Like, this is why this shit's fucking beautiful, is because shit like that happens.
Right.
And yeah.
Dude, I agree with you. Shit clicks into place and it opens up new doorways that you didn't know existed. And so it's just a very fulfilling thing. Like, wait, this is an answer that works? What?
Yeah. So look at, like, this is Euler's equation, or Euler's. I don't know. This guy.
Describe what it is to someone who is not seeing.
Okay. So it is the coefficient E to the power of imaginary I times pi, and then it continues the equation +1 = 0. And why this equation is so fucking mind-blowing is that E is an irrational number. It's like 2.7 on and on and on and on, because when you graph E, it I think it starts at -1, -1, and then it goes up like that, and it just goes on and on and on and on, up and up. But it looks like it plateaus, but it doesn't.
Okay.
So you're taking one irrational number, you're taking an imaginary number, and then you're taking pi, which is another irrational number. So you mean to tell me that two rational numbers, and then you take one to the power of it, and then an imaginary one number plus 1 equals 0?
Yeah, and it levels itself out.
Or even that, or if you take this little bit and then minus 1 to the other side of the equation, you're telling me that e to the I times pi equals -1? That's fucking nuts, dude.
The fact that shit just works. Well, it's so cool because you see it at first and you're like, what the fuck are you talking about?
Yeah.
But then like if you just give it time, like you said, give it time, let someone either explain it to you, or a lot of times like yard work. I'm a huge fan of yard work. I love yard work. And a lot of times it's like you can learn something Friday, Saturday, Sunday, you cram, right? You've been cramming, I'm down here, I'm learning about a lot of shit. And then during the week, Monday through Friday, I've been doing yard work here and there, blah, blah, blah. But in the back of my mind, as I'm doing yard work, I'm thinking about grass. I'm thinking about emptying my grass bag. But in the back of my mind, these equations and how I understand these things in mathematics or in the subject are working on it. And sometimes you'll have these, like you said, aha moments.
Yes.
Where you're like, holy shit.
Yeah.
Like you hear, like the bag gets full and your lawnmower dies, and for some reason that sound sparks. You're like, oh my god, I get the fucking equation,
dude. This is perfect. Hit
me with it.
Okay, so I was actually gonna first start with this story, but now that we've gotten to it,
excellent.
Oh yes, this is so great. Okay, so this dude, his name is Archimedes. He's he wasn't a philosopher. He was a mathematician kind of guy. And he lived in Syracuse in 250 BCE, like 250 before Christ was born, shit like that. So way back in the day, right? Way back in the day. And he's a smart guy, wicked smart, right?
Wicked smart.
And one day, he lived in Syracuse back in Greece, and the king apparently had given this goldsmith, or he was a newly appointed king and he wanted a crown. So he said, okay, I want to allot this much of gold to this goldsmith to make me a crown. And the goldsmith was like, all right, I'll make you a crown and I'll give it back. So the goldsmith went and made the crown, gave it back to the king, and all was well until king started hearing some rumors. That shit ain't all gold, man. Yeah. So
disrespect.
Yeah, I know, right? Like, so like the gold, like he was like, yo, did that goldsmith just like hack off like half this gold and like put a bunch, because silver is like also very malleable and like you can actually combine it with gold and it becomes kind of goldish in a way, I think. But I don't know, I'm not an alchemist, but anyways, the king goes to Archimedes because Archimedes is kind of like this fucking brilliant dude. He goes, dude, like, I heard like this goldsmith, it like ripped me off. Like, I don't know if like he's like took off with his gold and made an extra coin off of it, kind of thing. Like, is there any way you can fucking prove like, because it looks like it like normal gold crown thing. Like, but how can I prove that? And so Archimedes, he's like, all right, let me think about it, right? So Archimedes thought about it. And the classic story goes, he was in the bathtub. Homie was in the bathtub. And the coin, the term Eureka is from him. Oh, so apparently this fucking dude, he figured it out. He goes, Eureka. And the homie like got out of the bathtub and like streaked down the roads of Syracuse to the king, like this. Butt ass naked, just fucking going. He's like, I got it. Like, I figured it out, and it had to do with the bathtub. So, the in physics, the buoyancy is the buoyant force of an object is the same as the weight of the water, the volume of water. I know that's tricky, right? Okay. So I'll say that again. So the force, the buoyant force, is equal to the displacement of the volume of water. So
the weight of the object on the top of the surface of the water pushes.
Yeah. So if so that gold will try and be buoyant. So what happened? So what Archimedes figured this out. He goes, okay, I need exactly as much gold as you gave him, because they have like logs and shit back then. They're like, okay, right. King gave him this much gold. So what Archimedes did, he had a scale, right? And then he had like 2 tubs of water, So what he did was he put the crown on one scale, and then he put the same amount of gold on the other scale, and he submerged them so that they floated. And so if the crown was all good, it would have been equal in the middle. Right. But it wasn't, dude. So yeah, dude. Yeah. Like what ended up happening was like obviously I think the silver was lighter than gold. And so the scales was off. And so the king was like, fuck that. Because he goes, okay.
Goldsmith's fucked off of your head.
So because you put the 2 same amounts of gold on each side of the scale and then dip them in the water, that they'll be equal, right? So he was like, yo, if that scale's off, which it was by a long shot, he was fucked. He was like, you mix this with other shit and you fucking took the rest of the gold and made off with it. Damn. So fucking off of that motherfucker's head.
So hopefully that dude had skipped town. He's like, before they figure this out, before they measure a way to this crown.
Yeah. So yeah, it's that aha moment is that eureka. So yeah,
I think this is a good way to wrap it up, man. I think that kind of a lot what I do. Lessening the input sometimes is a lot of a good thing to do. Like so we're learning all week. You're learning. A lot of times we're stuffing our brains and blah 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 and stuffing it. And again, sometimes the best ideas come when you're mowing your lawn or you're in the bathtub. And these ideas can't come when you're constantly just trying to shove down more ideas, right? Yes. So when you're constantly taking information, whether could be good information, could be like, I'm so fascinated by everything that I just want to click on every YouTube video that I see. I have that all the time, but I do well now being able to like keep my brain working in the background, keep my subconscious mind doing the scientific method for me, sort of figuring shit out, as I'm mowing the lawn, as I'm in the bathtub waiting for my eureka moment. So listener, take some breaks. Yeah, definitely. Allow yourself some room for eureka moments. You never know what might pop up there.
Debug yourself.
Debug yourself.
Yeah.
If this, then that.
If this, then that.
Just figure it out. Yeah. Kelly, I love you, bro. It's been a pleasure to talk. I'm glad that you got to come and talk about, some things that you know about. I feel like I learned a little bit more today than I do. I always learn something when I talk to you.
I hope you guys aren't lost. If anything, if you guys are like, well, what did Kelly mean by that? Just talk to me. I'll explain it. So
yeah, bro, I'm glad. I'm grateful for you. I hope you have a good rest of your day, listeners, and I hope you enjoyed Kelly. I'm sure he'll be on in the future. We'll talk about some more complex stuff. Try to simplify it. Cheers. Have a good rest of your day.